All right, taking a look at number 1. We've been working really hard on trying to prove that two triangles are congruent. Now we're going to take our proofs a little beyond proving triangles are congruent and looking at other parts of triangles as far as angles or segments that we can start to prove congruent. So number 1 will kind of introduce us to our new reasoning, which is called the Cpctc, which is a way that we can use congruent triangles to prove other things are congruent as well. So number 1, we're going to tell why the two triangles are congruent using a postulate or theorem, and then give the congruent statement, and then list all other corresponding parts of the triangle that are congruent. So we'll start out by looking at the information given. We've got a side with 1 tick mark matched up over there with a side of 1 tick mark, and then an angle, and then a side. So we're going to see 3 parts there, and then we check. We've got an Sas congruence. So going around the triangle, I've got a side, angle, side, all consistently right in a row. That's going to mean I have a Sas congruence. So our first answer we'll say is Sas. Next, we'll say the congruent statement. So our congruent statement, we could say triangle KLJ is congruent to, if I start with K, I'm going up the side with 1 tick mark, so I'm going to say OMN. So there will be my congruent statement. Once you have your congruent statement, now all these letters are matched up the same as the angles and sides on your figure over there. So this is now something that we can use as we start to make other statements as well. Now here's where the Cpctc comes in. The Cpctc stands for corresponding parts of congruent triangles are congruent. So it's an acronym representing that long statement there. So you don't need to sit and write out that corresponding parts of congruent triangles are congruent. Don't have to sit and write that out. We can just use Cpctc. So we're now going to list other parts that are congruent. Once we have our 3 pieces that prove that two triangles are congruent, SAS or ASA, whatever we can use to prove it, other parts of the triangle are now also congruent as well. So like for example, angle K on the left triangle is going to be congruent to angle O on the right triangle. And again, I'm using my congruent statement, or I'm looking at the position in the triangle. K and O are going to be congruent. So since the two triangles are congruent, then any other parts of the triangle are congruent as well. And my reasoning is just Cpctc. So there's my reasoning of why those two angles are congruent. So you've unlocked now the rest of the pieces. Now we know that angle K, angle O are congruent. We already know that L and M are congruent, so the only other pair of angles left is angle J is congruent to angle N, and that's going to be because of Cpctc. So those are another set of angles that are congruent. Continuing, we got a KJ side is going to be congruent to an ON side, and that's going to be because of Cpctc. So there's our 3 other pieces that are now congruent. We started out the chapter looking at all 6 parts. Now we're kind of getting to that point where if we can prove the triangles are congruent, now we know all parts of the triangles are congruent. We can start to list off other pieces. I'm going to need to erase that problem 1. You guys okay if I erase that? So when you prove triangles congruent, now you have all 6 parts are congruent. And as long as you can use that congruent statement to match up those parts, you can start to now prove other parts of those triangles are congruent. We're going to skip down to number 5, which if you have your hard copy sheet will be on the back side there. And start to look at that proof. So our proofs are going to look just a tad different. We're not going to be proving triangles are congruent. We're going to prove in this one why KJ is congruent to QP. So we're trying to prove that this outside segment right here, this outside segment right here, this KJ, why is that going to be congruent to QP over here? So that's what we're trying to prove. But how we attack the proof is going to be very similar. We can prove the two triangles are congruent, just like we have been. Once we do that, now we can start to prove any parts are congruent. So I know that this one does say prove Kj is congruent to Qp. Let's just kind of put this on the back burner for now. Let's try to figure out three pieces of this triangle and this triangle that I can match up to make congruent, and then use one of my SAS, ASA, AAS, one of those to prove the two triangles are congruent. But first of all, can't get too far ahead of ourselves. We got to get our given information out there. So JK is going to be parallel to QP. Now, just because they're parallel doesn't mean that they're going to be congruent. And then M is my midpoint of PJ. So both of those will be my given information. And in both of these, there's no congruence yet that they're telling me, so I have no markings to make. So I have nothing up there yet that I can start to prove to get one of my sides or angles congruent. Number two, here's where I would look to use one of my postulates or theorems of things that don't need to be marked to prove congruent. Now the big thing here is I've got this X formation happening, X, which starts to produce these opposite angles. So what do we call those angles that are opposite in that X formation? Verticals. So we're going to have some verticals. So we're going to start to prove those two angles are congruent. I don't need markings. All I need is that vertical angles are congruent. So I'm going to start to say angle KMJ. And if I started with K, then I got to start with Q. So QMP are congruent. Now I can't just say angle M because angle M isn't specific enough. So angle M, it could be up here, it could be over here. So I got to use all three letters. So KMJ going that path, QMP going that path to represent that angle. And my reasoning is vertical angles. Number three. So far, we've only got one set of angles. We still need two other pieces, either another side and an angle or two sides. We still got a little bit of work to do. Now, the next thing is the JK and QP are parallel. So QP over here and JK are going to be parallel. And just to kind of help visually, let's extend those lines out. So those two are going to end up being parallel. But along those lines, we have this transversal that's cutting through. So there we have that figure that we've kind of seen back in chapter 3, where we have two parallels and then a transversal. Now in the triangle, we've got an angle here, and we've got an angle here, which are part of this diagram with my parallel lines, and they're also part of the angles in those triangles. So I can say this angle and this angle are going to be congruent because they're interior and they're going to be alternate sides of the transversal. So I'm going to have this angle, which I'm going to call angle J, and this angle, angle P, are congruent because of alternate interior angles. So anytime you do have parallels, you're going to notice that when you have parallels, that's going to be using that alternate interior angle. So let's mark that again right here and right here are going to be congruent. Angle J congruent to angle P because of alternate interior angles. Do we have enough yet to prove the triangle is congruent? Not quite. We've got one angle, two angles. We still need something else. We need a side. Well, that's where the midpoint's going to come in. So M is the midpoint of PJ. So it's going to make MJ congruent to MP. So we'll put that as our fourth step. MJ is congruent to MP because of definition of midpoint. Excellent. Now I'm looking at it. I can see forming. I've got an angle, side, angle. Up here I've got an angle, side, angle. So I've got three parts. They're in one of my theorems, postulates, ASA, ASA. I can now prove that those two triangles are congruent. I'm going to copy this angle up here, KMJ and QMP, so that I have that congruent statement all ready to go. So number 5, I'm going to say triangle KMJ is congruent to triangle QMP. And my reasoning there is ASA. Now that we've got the triangles congruent, we don't need any other information. We know the rest of the pieces are congruent as well, because if the triangles are congruent, then any other pieces are congruent as well. So over here, we were trying to prove that QP and KJ are congruent. Well, now I know QP, KJ are congruent because the triangles are congruent. So this 5th step, which I'm going to put in blue, 6th step, I'm going to put in blue. I'm going to say that KJ is congruent to QP because of Cpctc. So now I know that if the triangle is congruent, now this next step beyond the triangles, any other piece in those triangles are going to be congruent. So there's going to be my final step. So KJ, QP are going to be congruent because of Cpctc. So in section 4, we're starting to look at other parts of triangles, whether it be angles or segments, and then using that Cpctc. So in section 4, you'll have 3 extra proofs to practice. And based on the quizzes yesterday, those proofs you're going to be a little more comfortable with. This one with the alternate interior angles was the only type of proof that we had a little bit of trouble with. So hopefully it kind of helps you when you start seeing these parallel lines. That's when we're going to start to see those alternate interior angles. So I'll leave that up there if you want to copy it down later. But I'm going to let you loose the rest of the time. Then we got about 20 minutes. You can continue working on, maybe try to finish those last 3 proofs before you leave. I'll work on grades so you can see your quizzes going in here today at some point. But the rest of the time is yours.